Okay, there we go. As we go through today, if you have any questions, send them in using the question and answer part of the Zoom interface. Do not raise your hand or send it via chat. Send it via Q&A. And depending on the question, I'll either answer it as we go through or I will save it to the end. Um, I am going to talk briefly about some of the different technologies that you find in our access points. I will also spend some time talking about Wi-Fi 6E and Wi-Fi 7 independently, as well as going over the different access points that we have. So today, obviously, we're talking about our wireless access points. So these are going to be our dedicated business class wireless access points. So one of the first things I want to talk about here is our antenna technologies, because we do have some differences when it comes to our antennas compared to most of our competition. So we offer three main types of antennas. On our access points, we have static antennas. This is what you find in most access points that you would buy off the shelf, regardless of vendor, dual optimized and smart antenna. So your traditional static antenna is basically a fixed antenna that's built into your access points. Most access points are going to have an omnidirectional static antenna that's been optimized for ceiling placement. The assumption is you're going to mount these access points on the ceiling, and by and large, it's centrally located compared to where your clients are going to be underneath the access point. So we usually refer to this as omnidirectional or umbrella coverage. Now, the challenge that we run out to in the real world is you often don't get to mount your access points on the ceiling for whatever reason. You need to mount some of them on walls. And when you do that with a traditional static access point, you basically get less than ideal coverage. You end up sending a lot of your signal up into the ceiling and down into the floor, and you don't get as wide of coverage as you would get with an optimized antenna for wall placement. So our solution to this is what we call dual optimized antennas. So instead of doing like most vendors that have a single antenna that's optimized for the ceiling, with our access points that feature dual optimized antennas, you get two different sets of antennas basically built into the access point. One that's optimized for the ceiling and one that's optimized for wall placement. So that way you can go through and depending on where you've mounted that particular access point, choose to use either the ceiling or the wall pattern for coverage. So you optimize your coverage there. In general, our access points, if they support this feature, end in the letter D or the letters D-I to indicate that that model has dual optimized antennas. The other technology we have is our smart antenna technology. So this is something that you won't find in a lot of the other enterprise vendors like Cisco, Meraki, HP, Aruba. Um, you do find it though in Ruckus. So our smart antenna technology is very similar to Ruckus's BeamFlex Plus. So if you've installed and used Ruckus products in the past, our smart antenna is going to be a very similar situation. So smart antenna technology is designed to increase capacity so you can get more users on the same access point before you start seeing degradation. It allows us to cover a larger area. And key to the algorithm that we use for our smart antennas is we have optimized them to reduce interference. And that means it could be other sources of Wi-Fi, such as other access points. It could be other things like industrial equipment that are putting out RF interference. So as we talked about before, your typical antenna is just a static fixed antenna pattern that's usually optimized for ceiling placement. Anytime there's something that causes interference or is using that same RF channel that your access point is, you run into co-channel interference issues. So the way our smart antenna works is instead of having a single fixed antenna pattern, we have an antenna array built into the access point. So this antenna array has the ability to use hundreds of different antenna patterns and optimize it based on where the client is in relationship to the access point. And also with the algorithm that we have, we also take into account other sources of RF interference and choose an antenna pattern that not only focuses the signal strength towards the client, but also allows us to sort of ignore or not listen to those other sources of RF interference. So in a tough, crowded RF environment, this makes a huge difference when it comes to performance. It allows us in multi-AP environments to be able to get over 100% over 100% of the available airtime. So in theory, 100% airtime utilization is as far as you can go. With multiple smart antenna access points, you can get over up to 130 or more airtime utilization. I do a Wi-Fi 101 webinar where I talk a little bit more in depth on this and I share some test results and how that works. But just in general, smart antenna is going to get you better performance. We've got this example here. This is comparing our product, our WAX 650S, to an Aruba AP515. Both are 4x4, 5 gigahertz Wi-Fi 6 access points. So these should, in theory, have the same performance. But as you can see there, on both transmit and receive, we outperform them. Now, there was a number of years ago a university in Italy. Their networking group saw the claims that us and Ruckus were making about smart antenna technology. So their networking group got together and decided to test it. There's a link down there at the bottom. I believe that still works. That'll take you over to their white paper where they detail in extensive detail all the different tests that they ran and what the results were. So you can always look that up and find it for yourself. You can also just Google Zyxel Smart Antenna White Paper, and we've got a white paper that sort of summarizes things for you. But if you want the full uncensored, details of the tests they did and the results, you can find it on that link that's up there on the screen. But the short version is smart antenna technology does make a big difference, in particular in environments where there's a lot of co-channel interference. So again, co-channel interference just means what basically with Wi-Fi. And again, we talk about this in the Wi-Fi 101 webinar, but basically ignoring MIMO technologies, generally each device has to take turns broadcasting. You cannot have multiple devices broadcasting at the same time using the same channel. So anytime you have multiple APs in an area due to the limited bandwidth, you tend to get co-channel interference because some of those APs have to use the same channels as some of the other APs. There are also other additional sources of RF interference, particularly in commercial and industrial areas, that can cause this interference. So smart antenna outperformed regular antennas. Just in general, but in in environments with co-channel interference, which is most real-world deployments, it makes a significant difference when it comes to RF performance out in the field. So moving on here, we'll talk about some of the technologies you can find in our access points. Most of these can be found on any of our business class access points. Basically all of our W series access points and most of our NWA access points that have at least 3 numbers in the model name. So single click wireless mesh, all of our access points support mesh. We have 2 flavors of mesh, one version of mesh that works when you're using a local controller and a slightly different version that works when you're using our cloud management platform, which is I think what most of you will be using. And basically it just allows you to deploy access points in areas where there is no backhaul. They will automatically create a mesh with access points that you've deployed that do have an Ethernet backhaul to make sure that these still get signal and can provide coverage to clients. I would not recommend in general deploying a lot of APs into a mesh, but I mean, if it's good, if you've got an area where you're just, don't have quite enough coverage, you can extend an AP out there without having to run Ethernet to it to help provide that extra coverage. And by default, it is turned on in a mode where if for some reason an Ethernet cable gets cut to one of your access points, or for some reason they lose connectivity, they will automatically put themselves into mesh mode until that backhaul has been reestablished. We offer DPPSK, so dynamic personal pre-shared key. So traditionally, the way you should be doing your wireless security in a business environment is that you should be using WPA Enterprise for providing access to your employees and staff. And that uses what's called 802.1x to provide authentication for those users. So each user is normally going to get their own username and password. And depending on what level of security you want, you may also have special security certificates that they need to load on their PCs. This is the way you should be doing traditionally should be doing wireless access in a business. Unfortunately, for whatever reason, a lot of businesses don't go that route. Instead, they just use a single pre-shared key or a single password that all staff share. Now, obviously, there's security problems with that. People can easily share that to people who shouldn't have access to that wireless network, but you also run into issues when you have staff leave. Right? They still know what that password is. There's nothing stopping them from pulling into the parking lot and connecting to the Wi-Fi network after they've been fired, unless you change that pre-shared key for everybody, which is why we don't recommend you do it that way. So dynamic personal pre-shared key is a neat in-between way of doing things. It provides basically the level of security you get with WPA Enterprise, but with the simplicity of pre-shared key passwords. And basically the way it works is all of your users connect to the same SSID, but each user has their own unique password or pre-shared key. This is works just like any other pre-shared key, so you don't have to get IT on there to set up 8021X. Instead, you just give your user their password that they need to connect. They connect to the SSID with their password, and our system sees, okay, that password belongs to this user, and then we'll assign them access to the wireless network based on that. So basically, you in the back end associate that password with different VLAN settings, and then we implement those VLAN settings on a per user basis when they connect based on the pre-shared key they use to connect. So it makes it a lot simpler to deploy a wireless network where each user has their own unique password and access. With our Nebula Pro, so if you're paying for the Pro, extra Pro features on our free cloud platform, one of those sets of features you get is artificial intelligence or machine learning, however you want to put it, for our wireless access points. So basically, our Nebula Cloud will monitor what's going on with the clients as they're connected to the wireless network. And we have the ability to have our artificial intelligence automatically tweak some Wi-Fi settings based on what we're seeing as far as real world connectivity data from your clients on your wireless network. All of our access points, again, W series or the NWA series that are 3 digits or higher, are built with what we call RF first design. So there's two aspects of this. One is a longevity aspect, and one of it is a wireless performance aspect. So from a longevity standpoint, all of these access points have a lifetime warranty. So the way that we can do that is we've made some very specific design choices that are designed to increase the longevity of our access points. So when you're dealing with solid state technology like access points, one of the leading causes of failure is heat fatigue. Basically, heat builds up, you get heat cycles as things heat and cool, and you can have problems with the individual little micro switches that are part of microchips. Those can fail, solder joints can crack. So to combat this, you'll notice that all of our access points have a lot of vent holes on them to allow heat to escape the case. Some of our competition out there has no holes in it. But in addition to that, we have a large metal heat sink that you will find in most of our access points here that fits between the back of the housing and the back of the PCBA. This is designed to draw the heat off of the board and help vent it through those vent holes. Another thing that we do is we only use solid state capacitors. We do not use electrolytic capacitors in our designs because those tend to be much more likely to fail over time by either drying out, bulging, venting, all sorts of stuff. So we only use solid state capacitors, and that's why even our cheap $130 access point is going to have a lifetime warranty. And then when it comes to the RF first side of things, we have a lot more shielding on our boards than you will find in most of our competition. That's designed not just to help reduce EMI, electromagnetic interference. We've also designed most of our access points to be able to filter out 4G and 5G signals, which do neighbor a lot of the Wi-Fi channels and can cause interference, particularly in buildings that use a DAS system to bring cellular coverage inside the building itself. So we have that. The other thing we do is we do not mount our antennas directly onto the PCBA, but like most of our competition, including like Ruckus. Instead, we have our antennas mounted on their own PCBA with a shield in between the main board and the antenna board to help create better isolation between the antennas themselves and any source of RF interference coming off the board itself. So another cool feature we have here is the ability to basically turn some of our access points into a cloud managed VPN appliance. So this is a great way to provide coverage, uh, connectivity for your remote users to the office network without needing to configure software on the computer that they're going to be accessing, or without running into a double NAT scenario, which you often run into when you send a user home with a VPN appliance, which has to, which is basically a router that sits behind the router they've already got from their ISP. So with this feature here, this works with both Nebula and standalone, as long as you are using our security gateways. It allows you to create a secure VPN tunnel from the access point back to the office. There will be an SSID that you control through the cloud that grants that access. So in order to connect to that SSID, you do need a username and password, which you control in the cloud. You can also add in two-factor authentication to make sure only the user that should have access to that VPN connection does. But it makes it really super simple for the employee to be able to get their access. They simply take this access point home, plug it into their existing router, and connect to that SSID, and now they have access to all of their corporate resources. When it comes to outdoor access points, we've got a couple different solutions for you. On the lower end, we have our NWA 55 AXE. It's an AX 1800 outdoor access point. It's got two external antennas on it. Those are dual band antennas, so each one's doing 2.4 and 5. Those can be removed, and you can source your own directional antennas if you want to create a long distance bridge or something like that. But it's a cheap, affordable way to provide outdoor coverage for you. And these devices can be used to create a point-to-point or point-to-multi-point bridge. So if you've got a house and you've got a barn in the backyard and you want to provide connectivity to that barn, you can buy two of these, link them together, and then have Ethernet going into the barn to provide coverage there, or some other type of outbuilding. We have an outdoor enclosure. This fits most of our access points, and you can always find an updated list of compatible access points on our website, or just ask your salesperson. But it allows you to take an indoor access point and turn it into an outdoor access point. It helps protect the access point from water, and it also slightly raises the temperature range that the access point can function in when it's mounted outside. And then if you need heavy duty outdoor wireless coverage, we have our WAX655E. It's an IP66 rated enclosure. It has got 6 external antennas that you can hook up to provide your Wi-Fi coverage. We recommend our ANT 2105, which is sold separately, to provide that coverage. But you can source your own access points if you need a directional antenna or some other special high gain antennas for your application. It can use those. It just uses a standard N-type connector. So now I'll talk a little bit about Wi-Fi 6. Now, Wi-Fi 6 has been around for a few years, but I do find it's helpful to talk about it at least briefly here. So Wi-Fi 6 was the first major attempt at trying to solve some of the main issues that have been plaguing Wi-Fi since Wi-Fi first came out in 1999. Up until then, we've been making, a little bit faster speeds, little tweaks to it, but Wi-Fi 6 was the first major change that was designed to solve some of those problems. So it was designed to be up to 40% faster than 11AC Wave 2. It was designed to support a higher capacity of users. In theory, 11AC could support speeds near 10 gigs on the wireless data rate. And really key here, Wi-Fi 6 was the first major improvement to 2.4 gigahertz wireless coverage since 11N. 11AC, a lot of people didn't realize this, but 11AC only made improvements on the 5 gigahertz radio. So when you have a dual band 11AC access point, that 2.4 radio is still using 11N technology. So with Wi-Fi 6 now, you could upgrade the 2.4 radio and the 5 gigahertz radio. So that was really nice. I'm not going to go through all the little technologies that went into Wi-Fi 6, but one of the key things here with Wi-Fi 6, assuming you've got a bunch of Wi-Fi 6 clients connecting to it, is the aggregated throughput of all of your wireless clients basically stays the same. So in this chart here, The vertical axis is the aggregated throughput of all the wireless clients. And as we go on the horizontal axis, we're increasing the number of clients. So this orange line here is what we expect to see with aggregated throughput on 11AC versus the yellow line here, which is Wi-Fi 6. So what you see with 11AC and 11N and any of the older technologies is as you add clients to the access point, the aggregated throughput or the throughput that's shared amongst all of those users actually goes down due to the inefficiencies in how Wi-Fi has worked up until Wi-Fi 6. With Wi-Fi 6, if you've got only Wi-Fi 6 clients, the aggregated throughput remains basically the same no matter how many clients you get on that access point due to some of those technology changes that were finally implemented with Wi-Fi 6. So now we'll start talking about the Zyxel hardware. So to sort of make things kind of easy, we've grouped them into three categories for you: simplicity, flexibility, and ultimate. So the simplicity side of things is what I'm going to call basically our prosumer access points. These access points have a 2-year warranty. They don't come with our lifetime warranty that you find on our higher end access points. It's a 2-year warranty. And they're also missing some of the features that you would find. So for instance, here on the 50 series here, you don't have captive portal. You don't have WPA enterprise security. And you're missing some other features here like AP load balancing and stuff like that. If you jump up here to R90, you do add back in captive portal and WPA enterprise security onto those access points. But these are our prosumer access points. The 50 and 50 Pro are Amazon exclusives. 55AXE is our outdoor version of the 50, and it is available through distribution. And then our 90 series is what's being aimed primarily as if you're looking for something to buy through distribution, that's going to be the lowest end access points you'll find is the 90 series. Now, having said that, as you know, Wi-Fi 6E has come out, Wi-Fi 7 has come out. So we're starting to reduce some of our Wi-Fi 6 models. So the NWA90AX has limited quantity. It will be phased out some point here in the near future. Jumping up from there is going to be our flexibility series. The 90 that's right here, it really shouldn't be on here, but I'll sort of explain why it's there now. But in general, so ignore that for the moment. In general, our flexibility series is going to be anything that starts with NWA and has at least 3 digits in the name. So the NWA 110AX, the NWA 210AX, and the NWA 220AX are part of the flexibility series. So these models come with lifetime warranty. They are aimed specifically at the SMB business segment here, and for the most part, they have all of the features that you would expect to find in Nebula. So you might notice I mentioned the NWA 210AX, but I don't have it on the slide. That's because we have phased it out. There may still be a few floating around in distribution, but for the most part, the NWA 210AX is gone. We still have the NWA 110AX, but that also is limited quantity and will probably disappear here in the very near future. So that's why I have the NWA 90AX Pro. That is an option for you if you were buying NWA 110AXs. You may want to drop over to the NWA 90AX Pro. So the warranty is less and you're missing some of those features. But I find that a lot of people that were buying the NWA 110AX weren't using those features anyway. There's a pretty significant cost savings between the 90 and the 110. And the 90AX Pro supports 160 megahertz channels, so it can provide speeds up to double what the NWA 110AX had. And because of that, it also has a faster LAN port. It has a 2.5 gig or multi-gig Ethernet port for the uplink, where the NWA 110 only had a 1 gig uplink port. The other way to go, and the way to go if you used to be buying the NWA 210s, is to jump up to the NWA 220AX. It's a small cost upgrade, but it does support Wi-Fi 6E as an option on the second radio. So the second radio on the 220 can operate as either a 5 gigahertz mode or in 6 gigahertz mode for 6E. It's also significantly faster than 110AX and the 220 and provides that 2.5 gig uplink port on it. Jumping up there is our Ultimate series, and these are the ones that are really our true um, business class access points. So these guys here are all start with the letter W. So if it starts with the letter W, that's part of our Ultimate series. One of the things with the Ultimate series is most of our Ultimate series access points have one of our special antenna technologies on them. On this slide here, we've got all three models that support those dual optimized antennas I was talking about earlier. So you can see here there's a D on the end of the model name. That's how you know it supports dual optimized antennas. So we've got three models for you, the 510D, the 610D, and the 620D. So primary differences between these is this is an AX1800 product, this is an AX3000 product, and this is an AXE5400 product. In addition to that, the 610 and the 620 have a multi-gig uplink port, so 2.5 gigs, and they also have a 1 gig pass-through Ethernet port. So you could daisy chain another device from this. So instead of having to run, if you've got two devices in a room that need Ethernet, instead of having to run two Ethernet cables, you just run one to your access point and then one out of the access point to that other device. And just to be clear, that pass-through port does not provide PoE. So the connected device cannot be a PoE device, but otherwise it's passing through Ethernet, just like the access point was a switch. Another key thing on our W or the Ultimate series is going to be these models are all Nebula Flex Plus. So Nebula Flex Plus on our access points means that these can be managed standalone. These can be managed in our free Nebula cloud, or these can be managed by one of our security gateways. Most of our security gateway products have a built-in wireless LAN controller. So if you're deploying a lot of access points and for whatever reason you don't want to use cloud management, you can use one of our security gateways as a controller for these access points. And then on top of that, these do come bundled with 1-year Nebula Flex Pro. So that's an optional license that unlocks additional features on top of the free features in our Nebula Cloud. Jumping up there is our models that include smart antenna. So again, you'll notice here all of these models end in the letter S. That's letting you know these access points have our smart antenna technology we talked about earlier. So we've currently got three models that are Wi-Fi 6 or 6E. We have our WAX 630S, the 640S-6E, and the 650S. So all three of these have that smart antenna technology. The 630S is an AX3000 class product. Our 640S-6E is our only true tri-band Wi-Fi 6E access point. So this has three radios built in it. All three function at the same time. So you are providing coverage on 2.4, 5, and 6 gigahertz at the same time. The other 6E models we've talked about, the 220 and the 620, that only have two radios. So you have to choose whether to use 5 gigahertz or 6 gigahertz. 640S, you don't have to choose. All three are functioning at the same time. And then our 650S is just a Wi-Fi 6. It is not Wi-Fi 6E, but I would still consider it one of our flagship access points. So it is a AX3550 class product. It has a third radio in it that is used just for DFS scanning. So you can make almost instantaneous channel changes when using DFS channels. It has Bluetooth built in on it for IoT applications. Not a lot of you guys use it, but it is there for those of you that do need that Bluetooth beacon technology to be built into the access point for location purposes. It's got a 5 gig uplink port on it. So that's it for our Wi-Fi 6 and 6E access points. So I do want to talk a little bit about Wi-Fi 6E. I mean, I've told you which models have it. Short version is Wi-Fi 6E is just Wi-Fi 6, but it's been extended to support 6 gigahertz. So traditionally, Wi-Fi has operated at 2.4 and 5 gigahertz. A couple years back, the FCC and governments around the world have opened up a big chunk of the 6 gigahertz spectrum. So it's a new spectrum. It's a higher frequency. It's a much larger area that we can use. And it allows us to basically double the capacity um, on your access point. It gives us 7 super wide channels to use. And when it comes to indoor usage, there is no interference because there's no legacy indoor devices using this. So it gives us interference-free operation. The challenge, of course, with 6 gigahertz is going to be that 6 gigahertz, a lot of products don't support it, right? A lot of your smart home technology products still don't support 5 gigahertz. And with 6 gigahertz being new, a lot of products still don't support it. For instance, just this summer, Amazon added 6E support to their highest end Fire Stick, but all of their other Fire Stick products still only support 2.4 and 5. Apple, with the latest version of the iPhone, just now added 6E support to the iPhone with that latest model, but not Wi-Fi 7. So, it's one of those things where you're more future-proofing yourself probably with 6E support than it is that you've got a lot of clients that currently support it. Now, obviously, as time goes on, that will change and we'll get more clients that support it. But the main benefit here of 6E is just you've got this giant 6 gigahertz spectrum that you can now use. You can see here 2.4 plus 5 combined have less RF spectrum available than 6 gigahertz by itself. So it solves a lot of those interference issues because you have so much more spectrum to play with that you don't have overlapping channels with your access points. Now, there are some other negatives that go along with 6 gigahertz support. If you've sat through my Wi-Fi 101 webinar, you know that as frequency goes up, range goes down, and that's absolutely true with 6 gigahertz. So the range is less. So you will need more access points to provide the same area of coverage that you do today with 5 gigahertz. You can't just swap out your existing APs with 6 gigahertz and have 100% coverage on those 6 gigahertz channels. The other challenge with 6 gigahertz is you're not supposed to use it outside. There's a whole other set of rules, and you have to use a third-party software coordination solution to deploy 6 gigahertz outside. And not all, and those still haven't officially been approved by the FCC. They're all sort of a trial stage. So for that reason, you should only be using 6 gigahertz indoors. There are some vendors with some 6 gigahertz outdoor stuff, but again, to legally use it, it requires usage of a third-party service to do channel coordination. And again, that's something else I cover in a lot more detail on the Wi-Fi 101 webinar. But generally, why would you want 6E? Future-proofing your network. Also, like I said, you've got a ton of spectrum there. So if you control the clients and you have the ability to deploy 6E clients, you can put in a lot of coverage and not have to worry about interference. You get faster speeds, more users in your network. So those are the areas where you would want to deploy 6E. So just again to highlight here, we have 3 models that support 6E, the NWA220, the WAX620D, and the WAX640S. And of those, these 2 here, one of your radios is always in 2.4. One of your radios is selectable by you to operate in 5 or 6 gigahertz mode. So this is really handy to have as just a way to future-proof yourself. You can deploy today for your 5 gigahertz clients, and if you ever get enough 6 gigahertz clients support out there, then you can switch them over to 6 gigahertz support, or you can use those just to supplement and add 6 gigahertz to your existing network in areas where you may benefit from it. But if you want all 3 bands operating at the same time, our WAX640S is the model to look for. So now let's talk briefly here about Wi-Fi 7. So if you've been paying attention to all those emails we sent you, we launched Wi-Fi 7 last year. The first models started shipping in November of last year. So let's first just talk about Wi-Fi 7 in general. So Wi-Fi 7 came very shortly after Wi-Fi 6E. There was a very short gap between the two of them. And basically, Wi-Fi 7 builds on top of 6E. It supports 6 gigahertz. And a lot of the function here and the speed and the benefits we're getting are on that 6 gigahertz radio. So in theory, Wi-Fi 7 can support data rates up to 46 gigabits on the wireless side of things. We've increased QAM from 1024 QAM to 4096 QAM. which basically gives us a 20% speed increase. Basically, we're able to cram more data into the same RF spectrum. And we've now added support for 320 megahertz channels. Wi-Fi 6 and 6E supported up to 160 megahertz channels. So on 5 gigahertz radio, you've only had two 160 megahertz channels available. When it came to 6 gigahertz, you had 7. So now we've doubled the bandwidth that we can support up to 320. So now you really need to use 6 gigahertz to do this. But you end up in a situation where you've got 3 or 4 non-overlapping 320 megahertz channels. Wi-Fi 7 has also added the ability for clients to connect to multiple radios at the same time. So in theory, your client device can simultaneously be connected to your access point on 6 gigahertz, 5 gigahertz, and 2.4 gigahertz at the same time. So there's a couple different benefits when it comes to that. One thing you can do is you could aggregate those connections together to get even faster speeds, right? Distribute that data you want to send across all 3 radios. The other benefit of it is instead of doing that, you send the same data over 2 or more radios. So when packets get dropped, which they will, instead of having to wait for those packets to be rebroadcast, you hope that, if something interferes with some packets on the 5 radio, those packets went through successfully on the 6, and so you combine them together without waiting for the rebroadcast. So you end up with lower latency. So I think you'll find this is going to be a key thing when it comes to like voice over Wi-Fi. You'll probably find a lot of the voice over Wi-Fi phones and stuff adding support for this, so they can reduce that delay and reduce some of those sound quality issues you run into when you're doing VoIP over a wireless medium. And at some point in the future, you will have multi-AP coordination, the ability for access points to coordinate with each other in a standards-based way, to be able to make sure they're not stepping on each other's toes when it comes to RF usage, for distributing clients across those users, et cetera, et cetera. So it's a lot of stuff that's in there. Now, one of the key takeaways, though, when it comes to Wi-Fi 7 is so far Wi-Fi 7 isn't actually officially ratified. So everything that's out there today, including our products, is based on the Wi-Fi 7 draft spec. So at some point, probably this year, 2024, Wi-Fi 7 will officially be ratified. So until that happens, there's no way to know if the hardware that's available today will support all of the features that end up in the final version of the draft, or the final version of the standard. So it may be that you need new hardware in the future to be able to support all of the features. It may just be that you need a firmware update. We won't know until that happens. Zyxel is partnered with Qualcomm. We use Qualcomm for our Wi-Fi 7 APs, and we are one of their alpha partners. So we're working very closely with them, and we'll be one of the first ones to get firmware or software updates to enable new features as we go forward. But that is something to keep in mind. There are also very few Wi-Fi 7 clients because of this currently out there, and many of them aren't going to support all of the features that are out there today. So a lot of those early Wi-Fi 7 clients are not going to, for instance, support that multi-link operation, right? Because it's going to require more horsepower, which requires more electricity, which drains batteries faster. So, for phones and things like that, they'll probably not support some of those advanced features like MLO in order to be able to save battery and make their, so they don't run out of battery faster when using Wi-Fi 7. There is also a second release of Wi-Fi 7 that's expected sometime in 2025, and that will add features like the multi-link AP coordination to Wi-Fi 7. So it'll be similar to 11AC, where there was a wave 1 and wave 2. So right now we have draft, release 1, and release 2 at some point in the future. But in general, newer products based on release 1 and release 2 will still be able to interoperate and take advantage of Wi-Fi 7 access points you buy today. It may just not support all of the features that get added in the future. So our access point that's Wi-Fi 7 is the WBE660S. It is a BE 22000 rated product, so it gives us a wireless data rate in theory aggregated across all 3 radios of up to 22 gigabits per second. Again, that's data rate, not throughput. Throughput's obviously going to be significantly less than this, but it is a tri-radio Wi-Fi 7 access point. Ooh, that didn't work right. Well, shoot, my animation. There we go. There's my animation. That's what I wanted. I wanted to show you those here. These are our specs. So again, it's tri-radio. All three radios support 4x4 spatial streams. We have our cellular RF interference filter on there. This has our built-in smart antenna technology. It is Nebula Flex Pro. Um, and it is big and it is heavy. Due to the heat that this supports, to be able to support those faster Wi-Fi 7 speeds, the bottom of the case is a giant metal heatsink. It's really impressive if you get your hands on it. So that's our guy here. We will have a new lower priced Wi-Fi 7 access point available before the end of the quarter, hopefully. So that new access point is probably going to be targeting around a $200 street price. Well, obviously, it will be slower than this guy here. This one has built-in Bluetooth. That one won't. But affordable Wi-Fi 7 is also right around the corner as far as access points, is what I'm getting to here. These are available today. We may be sold out at the moment, but we'll have some more in here. If you are a Zyxel partner, talk to your salesperson. We have some very aggressive NFR pricing on these right now. And in general, we are significantly cheaper than anybody else with this class of Wi-Fi 7 access point. And that's it for today's webinar. Again, if you had questions, send them in using that question and answer interface in Zoom there. I have not seen any questions. While I'm waiting to see if someone's typing up some questions, to give you a second here, I do want to point out we are on YouTube, a Zyxel America channel. Zyxel is a big international company, and each region has their own Wi-Fi or has their own channel. Ours is Zyxel America channel. Most of our webinars are recorded and they are uploaded there for you. So if you missed a webinar or there's something coming up there, you want to share it with one of your coworkers, you can find them there. You can also find video case studies there, best practices things, all sorts of fun stuff on our YouTube channel. Admittedly, because we record all these webinars, there's a lot of duplicates. And then you can always connect to us on LinkedIn. And while I wait to see if there's any more questions, I will also point you to our forums. Really simple to get to, forum.zyxel.com. Those are user forums for you to talk to other Zyxel users, but our headquarters does monitor that, and every now and then our R&D or our tech support teams will answer questions there for you. But we do monitor your feedback there to give us ideas on what features to focus on and prioritize. It's also usually the best place to find the latest release notes, security bulletins, and things like that. So Enrique's got a question here. I think he's talking about our secure Wi-Fi, the ability to convert out of our access points into essentially a cloud managed VPN appliance. So AP to main office requires what type of corporate router? It's going to require one of our USG Flex or ATP series routers. So you'll buy those, and then there's a license to unlock it. I believe it is called Secure Wi-Fi on the licensing documents. So if you're looking for the license, that's the license you get it to work. But yeah, it should be, I think, any one of our USG Flex or ATPs. And I'll stick around for another few minutes in case somebody question pops up. But otherwise, thank you for joining us today. I appreciate you coming out. Enrique is also asking, how does our warranty work? So our warranty on our access points is a limited lifetime warranty, except for those that are just 2 year. But basically, the way it works is pretty straightforward. If there is a hardware defect, you're having some problems, you give our tech support a call. Our tech support is free. It is US based out of our Anaheim office. If you call really early in the morning, you will get redirected to our German office. We're based on the West Coast here, so we open up at 8 a.m. Pacific. So if you call in at like 8 a.m. Eastern, you will get redirected to our German support team. But again, it is Zyxel tech support. It isn't an outsourced call center. But anyway, you call them up, they'll do some troubleshooting, verify that the hardware is it is a hardware defect, and then they will arrange a replacement for you. So generally, you return the hardware, we check it out, and we replace it with an equivalent. You know, for several years down the road, it won't be the exact same model, but an equivalent access point for you. I hope that answered that question. Okay, looks like it did. Okay, guys, I haven't gotten any other questions, so I'm going to go ahead and end today's webinar. If you do have some more questions, hold on just a second. If you do have some more questions, go ahead and you can reach out to your salesperson if you're a partner, or you can email me directly, seanr@zyxel.com. Thanks for joining us, and I hope to see you at one of our future webinars.